I'm Martin Wilsey.
I'm Shay McGalley.
And I'm David Keener.
And this is the Hourlings podcast project. Tonight, Shay's driving a bus. Shay, take it away.
All right. Yeah, I'm excited for tonight's episode. We're going to cover the top 5 astronomy facts that every sci-fi author should be familiar with and figure out how they want to navigate. I definitely am very passionate about astronomy. I was an astronomy minor in undergrad. That doesn't mean that I know everything, and I'm still learning a lot about astronomy and enjoying my telescope nights. But as a sci-fi writer and a genre writer in general, I have to be familiar with some of these things when I'm writing in space or I'm writing in any foreign environments that might come across these scientific concepts. So we're going to go down this list and we're going to talk about them. And we might get into some debates. It might get heated. I don't know. But here we go. Let's do it. So, number 1, light speed is not as fast as you think it is. Now, I say this because a lot of sci-fi writers will say, yeah, okay, I just have to make sure that my spaceship can travel at the speed of light. And if it can do that, then I can just travel the universe and everything becomes much more accessible than what it currently is to how we can travel right now. That is definitely not true, because even if you could travel at the speed of light, which itself has a lot of difficulties that we won't get into right now. For example, the closest star to Earth would be Alpha Centauri, which is about 4.3 light years away. So that means it would still take your character 4 years of their life just to arrive at that star, which is really far. And you would have to account for how they're able to manage things with that much time going by, and what they've done on that journey for 4 years. So there's a lot more to talk about this number 1, but I'm going to throw it to Marty and Dave and see what they have to say about light speed not being as fast as you think it is. What do you guys think?
Well, a couple other facts about light speed. If you were to get on a spaceship and start traveling at 1G, which means you're accelerating constantly at 1G. Now, leaving off the fact that to do that for an entire year would take a lot of energy. In 1 year, you could attain the speed of light if you leave off all the physics variables associated with that.
Yes,
but accelerating at 1G gets you the speed of light in 1 year.
Yes.
And the interesting thing is once you're cruising, you don't have to accelerate anymore until you want to slow down. And then you turn around and slow down eventually. But there's a whole lot of other physics problems associated with cranking up that high. Most notably is time dilation and the fact that the closer you come to the speed of light, your mass increases to infinity, which is a problem for having enough energy to keep you accelerating. So fun stuff. But speed of light is really slow. Just
comparatively, yeah.
I know. Just that's like travel around the solar system. Speed. It's what, 8 minutes to the sun. That's provided you were going speed of light instantly, which is another problem in science fiction often.
Right, and in practical terms, it's very unlikely that you'd be able to get some kind of conventional drive anyway. It would get you faster than say 20 or 25% the speed of light, et cetera, et cetera. So your journeys would be even longer than just 4.5 years to get to Alpha Centauri. So which brings us to the first question that most science fiction writers writing in outer space have to come up with. And they have to go, am I going to deal with slower than light speed traffic? Or am I going to invent some kind of FTL drive, faster than light drive? Warp speed, warp drive, some kind of stutter drive, et cetera, et cetera. That's almost like the fundamental thing that you have to decide on when you're doing a science fiction set in outer space. FTL.
Yeah, or people might create solar systems that are extremely close to each other. The planets are close to each other. Might create fictional settings in that regards. I've also dealt with this myself and seen other authors deal with it by traveling through dimensions, like traveling through black holes, wormholes,
Hyperdrive.
antimatter, areas. But yeah, you definitely can't cut the mustard by just making light speed be your key to your passport, if you will, to the rest of the universe.
But that's one interesting thing about fiction. In science fiction, I think you're allowed one give me, right? One prerequisite that your story has to have that the reader just has to accept. And
no, I thought it was 2. And often I've read 3.
Okay, maybe.
Because like FTL and artificial gravity, those are pretty much gimmies in a lot of books, a lot of entertainment stuff.
But you get those few little prerequisites, and then you have to be consistent after that.
Right.
And of course, by gimmies, these gentlemen mean, having something be accepted or existing without plausibly explaining it, explaining the science behind it, the physics behind it, of how this happened.
Feeling suspension of disbelief. Yes.
Yeah.
It's called hand wavium.
I like it.
It's a scientific principle of writing.
Nice. All right, should we move on to number 2?
Sure.
All right. So number 2, I got some bad news for you guys that like to write sci-fi full of diverse species and aliens of all kinds, because currently the search for life beyond Earth is looking pretty dim. Now, of course, the probability seems to be rather high because of the probability of planets in the right proximity to their sun, and just how vast the universe is in general. Usually that's the first thing people would say to me when I tell them that it's looking pretty dim. They say, well, but the universe is so vast, surely out there life, let alone intelligent life, must exist. And that is a statistics that astronomers certainly accept. But we also accept the fact that right now the results for finding life are really discouraging. And this paradox, of course, is called the Fermi paradox, where it's if there is such a high probability of life in our galaxy, let alone in the universe, how come we have not heard or encountered intelligent life? And so this is a very real paradox I think that sci-fi writers need to deal with, especially if they are writing a far future Earth-centered novel, where it's a sci-fi, but Earth is still a planet involved in your setting. You're going to have to deal with the discovery of life. What does this mean? If this was such a very devoid subject for so many years, what does the appearance of life from someone on Earth, that perspective of someone on Earth, what does that mean for religion on Earth, for politics on Earth, for the economy, for everything? Because this would be a major surprise for us at this point, especially if we found life within our, near, we'll say nearby, quote, nearby, what's nearby in the universe. But yeah, so what do you guys think about this?
Well, I came up with a plot and a short story that completely explains why we haven't sensed any life in the universe. It's because they're hiding from humans.
Nice.
Because humans are the most horrible species in the universe. I mean, we breathe poison. We, eat other species' flesh for food, or worse, fun. We drink poison. We do all kinds of things that's really horrible and abhorrent to all the other alien cultures in the universe. So they hide from us because they don't want us to find out that they're there. So that's why we haven't seen any.
Very plausible, my friend.
Explanation for the Fermi paradox. I think you have to look at a couple things. First of all, I'm going to differentiate between intelligent life and life.
Mm-hmm.
Even if you looked at Earth, for most of Earth's history, there was not intelligent life on Earth. And if you really looked at it quantitatively, there's only been intelligent life for maybe, depending on how you count it, 2 million years out of 4.5 billion, or maybe 1 billion years when there was actually some kind of life on the planet, something like that. So it could be much harder to find intelligent life than it is to actually find a planet where there are creatures swimming in the ocean and flying in the air. So that's one distinction I'd make. The second is there's the Drake equation, which tries to put numbers to why we haven't encountered civilizations and stuff. And it could be, for instance, how long a civilization lasts, how far separated are they? So, for instance, life could be common in the universe, but if the next intelligent species is 1,000 light years away, and that it turns out that technical civilizations only last, a few thousand years, your odds of meeting one are very small. So,
right, because not only is it distance, it's chronology.
Yeah.
I mean, if another species out there within our vision had their renaissance, a million years ago, and now they're gone completely.
Yeah.
Who knows?
Trains that pass in the night, or ships that pass in the night, or something like that. Maybe you'd find remnants of long dead civilizations or something like that. That might be more likely.
Yeah, I also saw, I think it was a Carl Sagan show way back when, and they said that, well, maybe the universe requires this amount of time to brew up an intelligent species. And there's nothing that says that we're not the first ones to reach this level of technology. There may be other species right behind us that we haven't seen yet. And by the time we get around to being able to detect them, maybe we don't want them to detect us.
Yeah. But playing around with things like the Fermi paradox, why we haven't encountered other species, there's a whole bunch of science fiction books that have been written to kind of explain why not.
For sure, yeah. And I guess I'll throw in another little micro fact for viewers. That if your sci-fi is based still on Earth, the most likely place where intelligent life would be detected is at the SETI Institute, which is in Mountain View, California. And these are they have these enormous dishes that are looking for radio waves that might indicate communication or whether towards us or to each other of intelligent life. And so that would be if you were thinking of writing, a near future sci-fi where intelligent life is discovered, that would be a very, very accurate and plausible place for the discovery to be made. So also look into, these institutes around the world that are looking into this, and maybe even identify some scientists that are specializing in the search for life and incorporate them, or at least their studies and their methodologies into your writing. It could make it very plausible.
Here's a heartbreaking scenario for you.
Yes.
An intelligent species arises on a planet that doesn't have enough metal to actually form a technical civilization. So it doesn't matter how long they last, they will never produce radio waves, they will never produce spaceships, et cetera, et cetera. Unless they're contacted by those monkeys from Earth.
Any other thoughts
and then
on
let's just hope they're not very tasty.
Yes. If you guys, our viewers, if you want to look up more about the my claims about life, the search for life being rather dim, please do. It's a very interesting topic of looking for the likely places where we hope to find life, even on the micro level. The underground, not underground, the below surface, water that we're looking for. I think, Marty, you mentioned like the Goldilocks positioning of planets from their sun, and how that is, that's one thing that we look for when we're saying, oh, that's a high potential of finding life. But we're still, not detecting life. And so it's almost frustrating. It's like, oh, so much potential, so many planets where it should theoretically be a good place for life to be found.
Our sensors only go so far.
This is true.
Plus, a lot of the technologies that are used to detect planets are kind of oriented towards detecting really large planets, which aren't likely to be Earth-like.
For sure. Yeah, I mean, the next closest in characteristic to Earth is Venus, of course, but Venus is highly uninhabitable from our standards anyway. Maybe there's a very, very resilient microorganism on Venus.
Terraformable.
But I doubt it.
Tech.
Anyway, so let's move on to number 3. So the third astronomy fact that sci-fi writers should look out for is that weightlessness is one of the biggest health issues facing the human body in any sort of in orbit or in space. Of course, Marty and I were discussing this before we started recording, that the when you see pictures of our American astronauts floating, seem to be weightless. Many people do believe that that's because there is no gravity where they are, and that's not true. They're actually in orbit, so that means they're constantly in a state of falling. And this was exhibited by Newton's cannon, which showed, if the cannon, if you imagine a cannon atop a planet, a circular planet, imagine a cannon, it fires a cannonball, and if it fires it too slow, it'll just fall to the ground. If it fires it too fast, that cannon just goes right off the planet and keeps going forever and ever and ever in a straight line. But if you fire it at just the right speed, not too slow, not too fast, it falls into constant orbit around the planet in a circle, and that's why you get that weightlessness. But over time, that weightlessness is really bad on the human body. It hurts muscle mass. It wreaks havoc on the internal functionings of your body, and so over time, that'll be really, really bad. So sci-fi authors need to wrestle with any situation of weightlessness so that their characters are not going to be damaged by this over a long period of time. They need to think about countering this fact. What do you guys think about that?
Yeah, bone density too is really impacted, and they're shocked at how fast it actually impacts bone density. Your body is just completely designed to work with gravity. Function, it needs gravity to actually, have its peristalsis work right. A bunch of other stuff. Your blood flow, your body's designed knowing that your feet's at the bottom, and it's more work to pump the blood up from there than down from your head. It's a big thing. So I see it in the future. A lot of future space stations are being designed with spin gravity. So we'll see where that goes.
That's interesting.
I'm going to say centripetal force, please.
Yeah.
But yeah, so one of the things you have to decide in your story is how realistic you want to be. You could just do the Star Trek thing and invent artificial gravity and not worry about it. But if you really want to make it seem plausible, like this is really happening in space, and here's the things that they're dealing with, you're going to be designing different types of space stations and ships that spin in different ways to provide simulated gravity for the people on board. You can also get the stereotypical wheel space station, but there's also the possibility of, for instance, larger habitats, like imagine a cylinder 3 miles across and 10 miles long, spinning to provide 1 G on the inner surface, and you have farms and everything filling that cylinder. So if you place your story far enough in the future, you could be dealing with large space habitats like that are plausible and scientifically possible, but not quite something we can do with today's technology. But there's lots of ways to deal with it. But if you want to be plausible, you'll have to deal with it.
Yeah, I mean, I think that we could probably go on this topic for a long time about other things that would be really bad for the human body as far as space travel. There is a long list, and I know Marty alluded to it in the beginning about acceleration too. Would also be extremely dangerous for the human body. So yeah, you just got to think about how much you're going to be realistic about this and how much you want to explain. If you want to, I don't know, maybe there's more than 3 gimmies, Dave. Maybe there's a bunch of gimmies as long as you write a good story.
There's also some other technologies too. So for instance, I've heard good possibilities about like form-fitting outfits that help keep the skin toned, exercises in space, drugs that might help out with certain things, and an exercise regime under spin gravity, as Marty called it, that would be part of the regimen of everybody in space. So there's a bunch of ways to deal with it in your story.
Very good. Any other thoughts on that before we move on to our next?
Well, I think that one last thought would be some stories deal with issues like that too much, and it doesn't advance the plot, character, or setting or anything, and it turns into be a giant info dump. Don't do that.
That's fair. That's fair. All right, so let's move on to our next fact. I chose our next fact, number 4, to kind of give a nod to our military sci-fi viewers out there, ones who are interested in that genre. And this is to look out when your bullet misses its target in space, because Newton's first law of motion is that bullet is going to go on forever and ever and ever and ever and ever unless something acts upon it. And so I'm imagining a space battle right now with bullets and missed bullets just completely flying off the battlefield and going straight on and on and on, just to light years. It could go light years if it doesn't hit something. And so if combat is a common thing in your world, in your universe that you've created, maybe seeing a stray bullet flying by is very common as well in your world. This is perhaps a little bit of a silly one, but I wanted to choose something that would emphasize, specific genres in sci-fi can also be quite affected by science. So what do you guys think about this one?
I think it's a really great premise, and it's true, because you see a lot of space battles with massive railgun fires and countermeasures to shoot down missiles. All of those rounds are going to be going somewhere.
That's right.
It's just like, that's why comets still flying around. They blew off of something, and they're just cruising through the universe. I found it interesting. I read a story one time that talked about a gunfight on the moon, and it's interesting that standard rounds from certain firearms would actually send bullets in orbit. So shooting at somebody, the rounds might come back from behind you, Bugs Bunny fashion. So it's a very interesting premise to remember. There's a shooter's rule that says, be aware of your target and what's behind it.
Mm-hmm.
Like your planet.
Yeah. Well, yeah. Like, what would be the ethics of that in a sci-fi military or space, space force? What would be the ethics of that on such a macro level, right? When you have a huge, if you have a Death Star, kind of thing. What if that misses its target?
I think I have a couple of perspectives. One is if you're in sort of deep space, I'm really not worried about ammo ever returning. Yes, it might even orbit around the solar system. But on the other hand, we already have the Oort belt, which is sending comets and fragments and stones and meteorites and and everything into the inner system all the time. And so I don't see how the bullets and stuff would be much different. Now, if you happen to be close to a planet and you're shooting some heavy rounds around, things going at the relativistic velocities, and there's a planet behind you, well, something's going to get hit.
Yeah, and you got to keep in mind too that depending on what your projectiles are, the standard velocity, velocity of a bullet, it's only a couple thousand feet per second, and that's slow. If you're talking about an orbital body heading towards our planet, it would burn up in the atmosphere anyways.
I'm thinking depleted uranium shots fired at 50 or 100,000 miles an hour coming in through atmosphere. I'm not sure the depleted uranium is going away, and when it hits, it's going to hurt.
Yeah, somebody will have a bad day.
I mean, right
Yeah,
now,
it's
there's
really
only one
interesting.
person-
The debris that's in orbit's becoming a problem. You know, there's like lost wrenches and stuff that are starting to be a problem, impacting other satellites and stuff. Not just bullets.
Yeah.
It's getting crazy crowded up there.
Well, if you're going east-west at orbital velocity and something else is going orbital velocity in the north-south direction and you hit, it's gonna be ugly.
Yeah, because standard orbit, I think it's like 27,000 miles per hour.
Now, on the other hand, another rookie mistake that is made with Newton's first law of motion for sci-fi writers is the idea that your spacecraft needs constant propulsion to be accelerating, which is also not true. Especially if you've already, especially if they've already reached the velocity that they want to reach. If you want to change velocity, go ahead.
Acceleration requires, constant emission, but
and changing direction, changing velocity.
That's right. Once you attain that velocity,
right,
unless something else acts upon you, it will remain moving at that velocity.
So the idea of, where my character is going to get fuel for this long journey might not be as huge of an issue as you think it is. Of course, having some fuel for a very long journey would be a good idea if you need to change direction or change velocity. That's something to think about, though. That's where the law is in your favor.
It is something that can happen in combat. You had plenty of fuel to get to your destination and even to do some maneuvering for space battle. But now all your fuel tankage has been destroyed in the battle, and even though you vanquished your enemy, you're heading out towards Pluto and you have no fuel left. See ya.
And by the way, for our viewers, velocity, when we say velocity, it means speed and direction. It is both speed and direction. Any other comments, you guys, on Newton's first law of motion?
It's not just a law.
Speaking of laws, do you guys mind if I break a law real quick? I said I was going to do 5 facts, but I want to do 6. Can I do 6? What do you think?
I guess so.
All right. You're not
We'll
gonna
allow it. We'll allow it.
All right, cool. I'm going to hit you guys with one that I haven't run by the group before recording, because I think Marty would especially like this one, because Marty has a particular hatred for mono weather planets, don't you, Marty?
Yeah.
Or like mono temperate or whatever, just like one.
It was a rainy day on planet Mongo.
Yes. Yeah. Or like the ice planet that's all
just
ice.
a desert planet, just an ice planet, just a tropical planet.
Yeah,
that's
all right. So
don't forget the swamp planet.
Planet, of course, for the swamp monsteroids. Here's the 5th fact for you guys. That would be very unusual to have a mono-temperate planet because seasons are natural with revolving around the sun or revolving around a star. A lot of people don't realize that seasons do not change because of the distance of a planet from its star. They change because of the tilt on its axis. So let's see, I can't read. My hands are not high enough to do all my demonstrations for you. But if you imagine the sphere of Earth is tilted so that its pole is facing inward for some of the year, that would be summer for the planets in the northern hemisphere because the planet is facing towards the sun during that time. As it moves around the sun, the pole would then be facing outward, and then it's summer for the southern hemisphere countries and continents. So it'd be really weird to have a monoplanet that doesn't have any fluctuation in seasons in its orbit around the sun. I guess it could happen. I mean, I don't know. What do you got? Could it happen?
We're talking about Goldilocks planets here. Because if you expand it past Goldilocks, you can have a monoplanet that's like just a frozen rock. Pluto has probably got monoclimate. Let's just say that. And,
I guess that's true.
Yeah. So we're not talking about that though.
But nobody would live on those planets.
Yeah, we're talking about a Goldilocks planet.
Planets that are habitable, I should say. Which is
I couldn't design a planet to do that, but I could design a habitat that does that.
A habitat?
That, for instance, that habitat in space, the big cylinder, 10 miles long and 3 miles across.
Oh, I see.
Design a habitat that had perhaps a single monoclimate, but
Yeah.
I don't think you can design a planet. There's too many characteristics that I don't think you can control.
But I would say that
There is such a thing as a planet that, in addition to being off the vertical axis, like you were mentioning, it could be in an elliptical orbit, where in one part of the ellipse, they're closer to the sun than at another part of the ellipse. Those kind of planets actually do exist as well.
yes, but that wouldn't affect it not having seasons, right? Because at some point it would be further from the sun.
Right.
It would have a different.
Because at some point it would freeze,
Right.
just by proximity to, or it could be perfectly temperate when it's close enough to the sun.
Yeah.
But as the year goes by, whatever that year length would be, it would freeze and then burn. Maybe that's the extreme case.
I have one phrase for you: winter is coming.
But
Right.
all the monoplanets in like Star Wars, like Tatooine and Hoth and the Dagoma system or whatever it's called, those would I feel like those would not fall into the category of the planets that you were very rightly pointing out, Marty, about like the ones that are way far from their star and are frozen all the time, or the ones like Venus that are like on fire. Because all of those, they were still they had things growing, and there was a habitable planet. Hoth, maybe they had to work a little bit, but all those situations, I could not see them feasibly being one of those planets that are just entirely taken over by one climate, because it would just
you could have a monoclimate if it was all just a water planet. If it was all ocean everywhere.
Well, I disagree with that. I think you'd have ocean currents, and you'd have differences in temperature, and thus I think you'd have different types of animal populations in the colder waters than you might in the warmer waters.
And you'd probably still have ice caps or colder temperatures at the axes.
This is interesting. And I think it's something that sci-fi should think about. Just the seasons in general. Seasons. This is our and mine anyway. My too long didn't read takeaway statement.
And we've only tapped some of the possibilities. So, for instance, you could have an Earth-like planet that is a moon of a gas giant orbiting a double sun or something like that. Now you'd have to do some math and figure out some of the effects for your story and stuff, but that is a plausible environment.
Yeah, but my takeaway is that seasons are antithetical to monoclimate planets, and I think it'd be very rare to find a habitable planet that doesn't experience seasons. That's my takeaway statement.
Well, it's not just seasons. It's like when I think of a planet, even just Earth, I think of different seasons. I think of different ecosystems. I think of deserts. I think of tundra. I think of Death Valley. Scotland, where it rains all the time. I mean, all of those are different climates just on one single planet, and I've only touched a few places.
Yeah, and especially a planet with breathable atmosphere, because like Tatooine, if there's no oceans on the entire planet, it is not going to be breathable, because most of the oxygen that's created on Earth is created by plankton in the oceans. And if you've got a desert planet, you're not going to have it. Not going to have trees, not going to have,
Or that could be the purpose of the story, and you have to explain why. It was a living planet, but it's been destroyed in a nuclear war, and that's why nothing is left. Or there's some other plant matter that does it, or something.
Basically, Star Wars took a pretty big gimme on that one, right?
They took the simple way out.
They took this. All right, so that brings us to number 6, even though I said we're only going to do 5 because I broke a wall. But number 6, the last fact we want to talk about to our sci-fi writers is what someone would see on a planet looking up into the night sky. A lot of people don't really understand what they're looking at. And so, for example, the big white milky band in the sky that we see on a dark, I don't see it very often because I have too much light pollution where I live, but if you are lucky enough to live where you can see the stars very well, that band of light, most people understand it to be the Milky Way, but how can you be looking at the Milky Way if you're in the Milky Way, right? So this is explained anyway by a pancake. And unfortunately, this is not a real pancake. I wish it was. So imagine that you are a raisin in a pancake. And if you're looking towards the ends of the pancake, like over, my camera's not very helpful, but over here, you can kind of see where I'm moving. Over here, you're looking out that way, you're going to see the band of light because of all that condensed light with all the stars. If you're looking up, you're not going to see that band of light. You're looking out into the blackness of the universe. And so that's what you're seeing on perspective when you're on the surface and you're looking up. If you're looking towards the far end of the pancake, then you're seeing all that condensed light, and that's what makes the band of the Milky Way. So your character might see that, or might see something similar in their own galaxy. Or if they are in the Milky Way, they'll see the Milky Way. Other things your character might see looking up into the night sky, you might see, actually, let's go back to Tatooine for a second. There's two suns on Tatooine, right? That would be like a binary star system, which most scientists estimate that most stars are actually binary. So it'd be very common for your character to be able to see two suns or two stars with what they're looking at. Lots of other stuff that they could be looking at that's pretty cool. What do you guys want to throw out there that they could see in the night sky?
Well, I think the first thing people will do is they'll look at their night sky and they'll create their own constellations for wherever they are.
Yep.
And I think it's interesting when it comes to constellations that usually what people see and think of as stars are either 1, very close stars, or 2, very, very large stars very far away, or sometimes what they think is a star is actually a galaxy very, very, very far away.
And some are planets.
And actually, yeah, you're right, some are planets.
Yeah, I think looking up into the sky, imagine what it would be like looking up into a clear sky on a planet that had a ring, like Saturn. That'd be pretty cool.
Yeah, absolutely.
A lot of planets have lots of moons. You know, it could be dozens of moons.
Yes.
That would also be interesting. In stories like, remember Pitch Black with Vin Diesel? That was I think it was a trinary star system where it very infrequently became nighttime because of the positions of the various suns all the time. So you can actually do a lot plot-wise as a science fiction author with what is contained in the night sky. And it's another good way to differentiate, hey, Toto, we're not in Kansas anymore.
Yeah, no, I love that you brought up moons, Marty, because moons are definitely very common in solar systems. And an author might also consider whether their moon is tidally locked, like ours is or not. So is the character always seeing the same side of the moon, or are they seeing different sides of the moon? And does it look different at night? Tidally locked is when, so we're always seeing only one side of the moon. The other side, we call it the far side of the moon, because of the way that the Earth is rotating and the way that the moon is orbiting us. It's the perfect synchrony, so that we're always seeing one side of each other's face. And so maybe that's happening on this planet, or maybe you're seeing all sorts of different things as the month goes on. Maybe a month is different in your planet. Maybe time is kind of measured differently because of the orbit distance, the orbit speed. That's also we haven't really talked about that, but time could also be a very interesting factor with astronomy in your sci-fi world. Don't you guys think?
Oh yeah.
Yeah.
the day and the
It's
length
really
of the-
interesting because like something as simple as the moon, the concept that you just mentioned, there is a lot of weirdness associated with the moon.
Yeah.
One, the same side faces the earth all the time, which is very rare. No other moons in our solar system do that. And one day on the moon is actually 28 days on the moon, but one day is 28 days long. One orbit takes 28 days, and it just happens that that is what makes it face the earth the same, because one orbit equals one day. It's really interesting. So I don't know where I was going from there, but
I also have this image in my head that I feel like needs to be in the story, but I don't have a story for it. And you know, we're 2/3 of the way down the spiral arm of the galaxy. You know, but imagine, you know, somebody in a solar system above the plane of the galaxy that can actually look in their night sky and see the entire Milky Way with its whirl and everything hanging in the sky above them. I think that would be amazing.
yeah, totally amazing.
There's probably a system out there that where that would be possible. It might not be a habitable planet, but there's probably a system somewhere where that is possible.
And Marty, I have to correct you only because my astronomy professors would come and find me and hunt me down if I didn't. But Pluto and Charon are also tidally locked. Charon is
Oh, really?
Pluto's moon.
I was
Yeah.
not aware of that. I
But
learned
it-
something new today.
But is
I was
Pluto,
aware of that, but I was being nice.
well, I mean, you don't have astronomy professors. I have your name and number. But
And
but
yes,
hey,
Pluto's a planet, damn it.
I don't know. I don't know about that. I would have sided with you a couple years ago, but I've been convinced. I've been convinced. Yeah. So what we've covered the Milky Way, seeing galaxies, seeing planets. Anything else interesting that someone might see in the night sky that authors can run with?
Comets.
Comets for sure. Yep. Satellites. Other spaceships, perhaps.
Yeah, I've found reading the news lately about some objects in space that are causing anomalies. In particular, they were talking about a distant star that seemed to be phasing in and out, as if something on a regular basis was getting between the star and us. And they were speculating that it was a partial Dyson sphere around this sun that was moving on a regular basis. And I'm not sure the actual term that they're trying to coin for that, but it's a Dyson's cage, not a full encasing of the sun, but just like a cage around it that periodically was stopping us from seeing that light. Very interesting stuff.
That is
Yeah, I
very
thought
cool.
he came up with a reason for that, but I lost track of it.
I had not heard a plausible reason for that yet. Weird stuff though.
Well, I'm hesitating to let this episode go because it's been so much fun, and I could talk astronomy
And you
forever.
didn't even talk about black holes at all.
Well, a little bit about light speed travel, and how you can use them to, you know, maybe cut the track a little bit. But black holes could be a whole topic on its own. You could do a whole episode on black holes and sci-fi.
I will say one thing that I find interesting is that we live in a very boring, average area of the galaxy. And that's probably a good thing for life, because all the things that are really interesting, like black holes and really large suns and stuff, large suns tend to do supernovas, which is bad for life. Black holes tend to shoot out like jets of energy, which is also bad for nearby planets and stuff. So we should be glad that we live in a boring average area of the galaxy. I'm just saying.
Yeah,
that's true.
I remember reading an essay about black holes and a theory about them. And this theory speaks to something else we talked about earlier, alien civilizations. Sagan postulated that the reason why we hadn't seen any alien civilizations is at some point they advance far enough that they create nuclear weapons and destroy themselves. And that's why we haven't seen any. Stephen Hawking updated that theory. This was just before one of these big particle accelerating colliders was going to come online. And he made this statement because the scientists said, oh, there's only a little slight chance that this collider will generate a black hole. And the thing is, if it did, we'd have a really bad day for that one day. So Hawking's postulation was all those black holes that we can perceive in the universe used to be an advanced civilization that invented a collider, and they wanted to see what happens.
Whoops.
So when there's a big sign next to a big red button that says "Do not push," we will push it, and it will become a black hole. Is the moral of the story.
It's interesting that since I read that long time ago, I think it was the Hadron Collider that was coming on back in the day. It's a heavy ion collider. They have in fact created strange matter. Black holes are considered to be a type of strange matter, but you know, it's weird. You know, scientists, you know, just because they can doesn't mean they should.
Like Jurassic Park.
A fiction book where humans had created some kind of super device in space, and their first sign that there was another intelligent species in the universe was that species detected their earlier experiments with it and destroyed it, because it tends to do bad things to entire sections of the galaxy if you get it wrong.
Yep.
I would much rather see stars and planets than black holes when I'm on the surface of a planet and looking up. So stick with stars and planets, people, unless you want an apocalyptic sci-fi coming at you. And by the way, do you guys know how to tell a star from a planet when you're looking up at it? Planets don't twinkle. Stars twinkle, and planets, when you look at them, they're steady light, and it's because of the turbulence of the light entering into our atmosphere. So planets are closer, and it doesn't have that kind of blinking on and on effect as the light comes in. So that's how I do it now, because I have a hard time telling them apart, because like Mars, you know, it looks kind of red, but so do cooler stars, so look kind of red too sometimes. So and whenever I'm in doubt, or whenever you're in doubt, look for the one that's not twinkling, and that's a planet.
I have this great app on my iPad and on my iPhone that you can hold it up to the night sky, and it knows the direction that you're pointing.
Nice.
Elevation, and so it allows you to spot celestial bodies, planets,
nice.
know, even satellites and things like that. It's pretty cool.
That's
okay.
awesome.
What's the app?
I think it's called
Dave Keener always asks the hard questions in the middle.
Oh, that's right. Hardball with Dave Keener.
Yeah.
Science moment, hardball. Please. It's called Sky Guide.
Nice. Yeah, I think we'll have a lot of links to drop into the chat, into the description for this episode. I'll give you guys the link for like the search for extraterrestrial intelligence and all sorts of things we mentioned.
And it's got like constellations and stuff in it.
Yeah.
It moves as you move. It tracks certain special stuff. Is
it free?
Yeah. It's really
That's
cool.
Great. Yeah, so think about downloading that app, people. If you're using a desktop, I use Stellarium. That's also free, and it's really cool to play with. And you can see how the stars looked like 10,000 years ago and how they'll look 10,000 years in the future, predictably. It's really cool. So think about downloading Marty's app, Stellarium, brush up on your astronomy, and you'll have a pretty awesome sci-fi novel on your hands. So thanks for tuning in. We'll do this again sometime, and take care.
Thanks.